Hello guys, welcome back. This is me, Bandar Dolbet. In our today's video, we are going to talk about velocity time graphs. Well, as you see here, we have 5 different velocity time graphs. Each one has a different interpretation or description. And before we jump into describing these velocity time graphs, let us first answer a very important question here, which is what velocity time graphs tells or shows. As you see here, to answer this question, let us take example A here, the velocity time graphs A here to answer this question. Well, in this graph here, in the y-axis, we have velocity in meters per second, and in the x-axis, we have time in seconds. So that's mean what? That's mean we have a velocity plotted against time. And when velocity plotted against time, that's mean the change of velocity over time. And change of velocity over time is actually the definition of acceleration. So that's mean what? That's mean the velocity time graph tells the acceleration of the moving object, The second thing is, guys, as long as we have velocity and time, then we can calculate the displacement or the distance traveled. So the second thing that a velocity time graph tells or shows is the distance traveled by the object, or the displacement, the distance traveled or the displacement. So moving back to our velocity time graphs here, and how to describe them, let us start with A here. So first, let us look at the line here. We have a straight line that divide the graph into two equal parts. So whenever we have a straight line that divide the graph into two equal parts, then we have a constant acceleration. Constant acceleration. What do we mean by constant acceleration? That's mean what, guys? Constant acceleration means that the speed or the velocity of the object is changing or increasing with the same amount each time. Means what, guys? That means that the velocity, constant acceleration here, means that what, guys? Means that the velocity here, velocity change, or let's say increase or also decrease, increase with the same amount every time, with the same amount each time. Okay, moving to velocity time graph B here, we have a steep line. The steeper the line, the greater the acceleration. The steeper the line, the greater the acceleration. Hopefully this space is quite enough. So here, that's mean here in this velocity time graph B here, we have great acceleration. So here, this is interpreted as great acceleration. Great acceleration. Okay, moving to a velocity time graph C here, we have as you see, a shallow line, and a shallow line here, interpreted as what, guys? Shallow line in a velocity time graph interpreted as what? Low acceleration. Here, this graph interpreted as low acceleration. Okay, and moving to a velocity time graph D here, as you see here, we have horizontal line, and a horizontal line in velocity time graphs interpret it as constant velocity, constant velocity, not a constant acceleration, instead constant velocity, guys. Why it is a constant velocity? Because, for example, let's say here we have the velocity is 5 meter per second. So as you see here, by the time change, we do not have increase or decrease in velocity. The velocity is still 5 meter per second. So that's why it is interpreted as a constant velocity. A horizontal line in a velocity time graph interpreted as constant velocity. Okay, and what about velocity time graph E here? We have a downward line. As you see, this line goes downward. So as long as we have a downward line, if we calculated the gradient of this line, we will find that the gradient is negative. So here we have a negative gradient in velocity time graphs interpreted as what, guys? Interpreted as negative acceleration, negative gradient. And negative acceleration, negative gradient means that we have a negative acceleration. And negative acceleration means what, guys? Means that we have negative acceleration and negative acceleration before. In the acceleration lesson, we defined it as, or we had a name for it. If you remember, it's called deceleration. Deceleration. So this is all about interpreting a velocity time graphs. Here in we have 5 different velocity time graphs. To conclude all this, we said that velocity time graph tells the acceleration of the moving object, the distance traveled, or the displacement of the object. Also here, to interpret a straight line in velocity time graph, we said that the straight line means we have constant acceleration, and constant acceleration means the velocity increase with the same amount each time. And in velocity time graph B, we have a steeper line, and the steeper the line, the greater the acceleration. So we have great acceleration. Here in C, we have shallow line, which is mean low acceleration. In D, we have constant velocity. Straight line, horizontal line means we have constant velocity or not changing velocity. In E, we have a negative gradient or negative acceleration or deceleration. Okay, guys, if you like the video, please hit like and subscribe to my YouTube channel so that I can make more content like this. See you in the next part.